Let's look at this example. A farmer can buy two types of fertilizer, Grow 'em Quick and Green and Tall. Each cubic yard of Grow 'em Quick contains 20 pounds of phosphoric acid, 30 pounds nitrogen, and 5 pounds of potash. The amounts of phosphoric acid, nitrogen, and potash are also given for each cubic yard of Green and Tall. At a minimum, each month we need 460 pounds phosphoric acid, 960 pounds nitrogen, and 220 pounds of potash. Grow 'em Quick costs $44 a cubic yard, and Green and Tall costs $32. Now we need to decide how many cubic yards of each mix should the farmer blend to meet the monthly requirements and minimize cost. And then we want to know what the minimum cost is. So the first thing we want to do is define our variables. So let's let x be the number of cubic yards of Green and Tall. Now let's make it Grow 'em Quick. And we'll let y be the number of cubic yards of Green and Tall. We can make a table that summarizes the information for Grow 'em Quick and for Green and Tall. So x, y, we have information about what? Phosphoric acid. We have information about nitrogen. And we have information about potash. Okay, we also know the cost for each of these. So Grow 'em Quick contains 20 pounds of phosphoric acid, 30 pounds of nitrogen, 5 pounds of potash. The other one contains 10 of the phosphoric acid, 30 pounds of the nitrogen, and 10 pounds of the potash. We are given some total monthly requirements for these. We need 460 pounds of phosphoric, 960 pounds of nitrogen, and 220 pounds of potash. Let's look at the cost. 44 cubic yards for, $44 for 1 cubic yard of Grow 'em Quick, and $32 for a cubic yard of Green and Tall. Now we need to write our mathematical model. First, decide if you're minimizing and maximizing. Minimal cost. That means we are minimizing cost. So I'm going to call that C, and we need to write an equation for it. How much total money will we spend fertilizing our plants? We know that each cubic yard of Grow 'em Quick costs $44. There are X of them, so we will spend $44X on Grow 'em Quick, and we're going to also spend $22Y total on Green and Tall. And we're going to be subject to these constraints. Okay, let's look at phosphoric acid. We are given a minimum monthly requirement for phosphoric acid total. So you ask yourself, does that mean less than or equal to 460 or greater than or equal to? Minimum means it's okay to be more, but it cannot be less. So what direction does our inequality sign go? That puts me at greater than or equal to 460. It cannot be less. How much phosphoric acid do we have? We have 20 times X plus 10 times Y. In other words, 10 per cubic yard times Y, which is the number of cubic yards of Green and Tall. We're going to do exactly the same thing for the nitrogen and the potash. For nitrogen, that's also a minimum requirement, so that means it can be larger, but it cannot be smaller. So greater than or equal to 960. 30x plus 30y. The potash has to have at least 220 pounds of potash. So that'll be 5 times the number of cubic yards of Chrome Quick plus 10 times the number of cubic yards of green and tall. So 5x plus 10y greater than or equal to 220. Now ask yourself, do negative numbers for your variables make any sense realistically in the problem? Occasionally they will, many times they won't. In this case, it doesn't make sense to purchase a negative number of cubic yards of a brand of fertilizer. So I put in my non-negative constraints. X, y greater than or equal to 0. This is my mathematical model. Okay, now we need to graph our lines and find our feasible region. So first, if we look at this line, let's find the x and the y intercepts. If I put in 0 for x, I get 46 for y. If I put in 0 for y, I'm going to get 460 divided by 20, covering this up. 460 divided by 20 will be 23. So we have 23, 0 here. Move to the next one. Put in 0 for our x. So think of this term as being gone. 960 divided by 30 will be 32. When we put in 0 for y, and we're also going to get 32 for x. We move to the last one. Put in 0 for x. So this term is gone. 220 divided by 10 gives me 22 for y. Put in 0 for y. 220 divided by 5 gives me 44. And so here are my x and my y intercepts. Okay, now I do my scale. I probably don't want to draw 44 tick marks. So what I'm going to do is I'm going to do my tick marks in tens and estimate the rest. I know my x's and y's both need to go into the 40s, so let's do 10, 20, 30, 40, and 50. And similarly for my y's, 10, 20, 30, 40, 50. Okay, we'll put our individual x and y intercepts in and just be sure we label them carefully. Since we don't have tick marks for everything, we look at the first one. We have 0, 46, so that'll be about right here. So I'll label my point. 0, 46, 23, 0. If you run out of room, just bring it down here. You just want to make sure you know what it is, because this could turn out to be an important corner point. You don't want to have to go recalculate it. Okay, and we label our lines. So this one is 20x plus 10y equals 460. Then we have 0, 32, 32, 0. So I draw and label my line. And then one more. 0, 22, 44, 0. I have room to sneak that one in like that so it's a little less confusing. Okay, so here I have 5x plus 10y equals 220. Now we need to find our feasible region. Here, notice we have this little tiny triangle in here. This is one of those places where you could really mess yourself up if you didn't have a straight edge, because these might intersect a little bit different way. So it's very important to use a straight edge and be neat when you do your graph. So now we want to look at which way our shading is going to happen. If we use for all of these, once again, we can use our test point of 0, 0. And so the first one is going to give me 0 greater than or equal to 460, which is false. And so there we're going to shade away from the origin. Which one was that? This one. Shade away from the origin. We move to the next one. That's going to give me 0 greater than or equal to 960, which is also false. And let's go ahead and do the third. 0 greater than or equal to 220. So in all of these, we'll be shading away from the origin. So this one shades away, this one shades away. And so then what's our feasible region? This area out here is our feasible region. Let's draw it. So we want to go along here. So you just want to make sure that your feasible region is clear, and you want to make sure that you know where your corner points are. So what do I have for corner points? Here's one corner point, here's a corner point, here's a corner point, here's a corner point. So we have 4 corner points. 2 of those we can just pull right off of the graph. The other 2 we're going to have to do some work on. Let's call these 2 A and B. So now we need to find those. Let's move down here. Okay, so for A, which lines do we need? We need 30x plus 30. Y equals 960. We also need 20x plus 10y equals 460. Let's do elimination. I'm going to multiply my second equation by -3. That'll give me -60x, -30y, -1380. And we're going to leave the top one as is. So here I have -30x, my y's disappear, and I have -420. 42 divided by 3 is 14, so my x is equal to +14, which seems reasonable based on my graph. Put that into one of these equations. Let's put it into this second one, 20x plus 10y equals 460. So 20 times 14 plus 10y equals 460. 280 plus 10y equals 460. 460 minus 280 is equal to 180. So y is 18. And so now we have the point 14, 18, which looks pretty reasonable on my graph. Mine is not quite right because it actually looks like my y should be larger than 20, but I'm a little bit off in the way that I drew it and everything's not quite to scale, but it's close enough that I think it's reasonable and that I don't think I did the arithmetic incorrectly. Let's do B. For the other corner point, what do we need? I'm going to go back up and see which lines I need. Based on my label, my carefully labeled lines, I need the 960 and I need the 220. Those are the ones that intersect at B. So I have 30x plus 30y equals 960, and I have 5x plus 10y equals 220. If I multiply this one by negative 15, I will get negative 30x, negative 150y equals negative 660. Hang on, I wrote that I multiplied it by, let's start over. What do I want to multiply it by? I want to multiply that by 6. Actually, let's make it negative 6. So let's multiply it by negative 3. I'm sorry, I think I had some of this multiplied out, written out beforehand, so you wouldn't have to wait for me to do all the calculations, and I'm afraid I copied something wrong. Let's do, if we multiply that by negative 3, we get negative 15x, and we get negative 30y, and we get negative 660. Now that makes sense now, and we're going to copy this one just the way that it is. So 30x plus 30y equals 960. Add these, we get 15x. Here we get 300. And so then my x is 20. Put this into one of your equations. Let's put it into the second one. So 5 times 20 plus 10y equals 220. Subtract 100 from both sides. 10y equals then 120, and so my y is 12. So we end up with the point 20, 12. We look back at our sketch to make sure that looks reasonable. Again, I'm a little bit off in the way that I drew it because my tick marks aren't exactly the same distance apart, but it looks pretty close. It certainly looks reasonable. It's not far enough off to make me feel like I did my arithmetic wrong. Now let's write down our corner points and calculate our objective function at each of them. Instead of writing objective function, I'm going to actually write it down myself. Let's go up and look at what it was. And I don't know if you noticed this, but I actually noticed just now. Is it correct? Let's look at it. How much does our fertilizer cost per cubic yard? $44, $32. So what should this one say? This one should say $32, and so then this should be 32y. So please make that correction. And let's go down here and write that into our table. So 44x plus 32y. What are our corner points? Well, we just found 14, 18, and 20, 12, but there are two more that we'll find if we go back and look at our sketch. What else do we have? We have 0, 46, and we have 44, 0. So we also have these two corner points. Don't forget those. 0, 46, and 44, 0. So we do the calculations. Here we have 44 times 14 plus 32 times 18, which should turn out to be 1,192. And then if you do 20 times 12, you get 44, sorry, not 20 times 12, but the order pair 2012, 44 times 20 plus 32 times 12. Make sure you calculate along with me. You should get 1264. Here, the first part will be 0. Now we have 32 times 46, which is 1,472. And now last we have 44 times 44, which is 1,936. We do have an unbounded region, so we want to make sure we look at it and see what is happening as x and y get large as we go toward the infinite part of my unbounded region. As x and y get very, very large, we will be heading out this way, and that will cause my c, my cost, to become very, very large, so we'll certainly be moving away from the minimum rather than toward it. So this will have no max, but it will have a minimum, and my minimum will be the smallest of those values at my 4 corner points. So the smallest is this one. So that's my minimum. And so now we're going to write down our answer. The farmer needs to buy 14 cubic yards of, what was that first one called? Grow 'em Quick. Second one was Green and Tall. And so 18 cubic yards of Green and Tall. For a minimum cost of $1,192. You can see that if you just were to change the costs of your two types of fertilizer, your corner points would remain the same. But which of these is at its minimum, which of these gives you the minimum, will change.